Alright, and we are live at this moment. So last time we just finished up the instancing of Vulkan. Um, actually it looks like we just created the window. Um, yeah, it looks like we just created a window, and that's pretty much it. So, or is this the right? Give me 1 second. Let me make sure it's the right. Uh, my bad. I was in the wrong folder. Let's get that up there. So now last time we just worked on the engine. Here's our Vulkan context and our window. So we got that working, or started out. Let's make sure we are destroying the instance. Or take a look in the instance code here. And yep, we are destroying the Vulkan context. Now, today we are starting to get into the validation layers. And validation layers is basically the is the debugging, logging stuff, and all that jazz. But let's make sure. So I am having a sandbox core and another sandbox. Okay. Core sandbox. Okay. So I'm gonna bring in SPD log into the workspace. It is a good logging tool. You can see more from the channel, but that's pretty much all I'm gonna say. So let's do a git submodule add SPD log vendor SPD log. Okay, all downloaded. Let's add that to our repository, or to our workspace file. So premic 5 include directory SPD log vendor SPD log, and this is going to be under include. The core is gonna have it, so includes directory SPD log. So we got that going. That's also put it in the sandbox. Why not? Include directories SPD log. So what we are doing now is we're going to create a logging system, or the logging classes. So what we can do is a new file called log.hpp. Pragma once. Let's see here. Namespace YouTube class log, and what I'm gonna do is pretty much copy code, but I'll go through it. Fine Slack. I got so many projects. It's hard to keep up, but sudo engine cpp. Here we go. Include core and log. So we do have a public log method, destroyer, static void init, inline static sv. We're gonna have a shared pointer. SPD logger. We're gonna have multiple loggers later, but this is a general return logger. Static shared pointer SPD logger. So we got that HPP going. Let's create a new file, call that log cpp, and this is our basically our implementation file. So include log.hpp, namespace YouTube, log destroyer, and let's get into the source. So nothing much in this implementation here. Don't know why I have it anymore, but we need to declare the loggers before we can do anything. So std shared pointer, std logger, log as logger, and now we init log. So in this init implementation, we want to set the pattern. I'm gonna just copy some code here, or the pattern that I like. SPD log at empty logger, and then we wanna set the level to trace mode. And that's it. That should be all the logging stuff. Now all we need to do is go to the sandbox application. Okay. Sandbox application and initialize the logger. Once we have that initialized, that's pretty much it. We can say yt log get logger info application. Now we need to do all the include stuff now because I bet I forgot all of that. Include log.hpp Vulkan content. Here we want spd log dot spd h we also want the pch. Let's now generate the premake 5, premake 2, and make it. And I bet there's gonna be an error. If I'm, oh, whoa, adding a new, oh, yeah, okay. So, we forgot a semicolon. That's pretty much it. Here. Yep, just a semicolon, and there we go. We got Vulkan supported, started Vulkan, and yeah, destroyed Vulkan. So we get that going. We didn't really need to get the SPD log, but it's a good library to have. Let's see here. Let's see. Let's see here. Init, start an application, and let's go to the the Vulkan. So Vulkan supported. We can say Vulkan support. And then when we create our context, we go to the definition here. And then what, say, Vulkan destroyed. Destroyed and Vulkan created. Make it. Should not have any errors, but never know. And I think I actually forgot one thing. Well, is it in here? In the main? I'm not sure, but anyways, if we run it, supported and created. Now if we destroy, close window, Vulkan is destroyed. So we got that going. Now let's get the validation layers started. So back to context here, we want the context.hpp file. I'm gonna add a I'm gonna do some tidying up here because this file is gonna get very big. So create, and then destroy. So void create. Okay, validation layers. Validation layers. And then void destroy validation layers. Implement those, void, create validation layers. Void Vulkan context, destroy validation layers. And yeah. Using validation layers. So I'm reading up so some of the code I'm actually gonna steal off of this site because it's decent code and why leave it to waste. But there's also multiple videos and multiple ways you can do this. Like the way that I implemented validation layers on Sudo engine is completely different than this. And yeah. So let's start into it. So we are using pch.http, but what we need now is a std vector of const char pointers. Validation layers. So this is our validation layers. It looks like it's gonna, yeah, it's just a constant vector. I'm gonna keep it as a member because, yeah, I'm gonna keep it as a member just because. I think this would work. I'm not too sure with C++. Okay, Chronos validation. And then a debug variable. But I'm gonna keep it going for now. I'm not gonna keep a debug variable because this is not meant for release. This is somewhere to learn about Vulkan. So back in the Vulkan context, let's see if our layers are supported. So un32_t layer count vk enumerate instance layer properties layer count null pointer. So this right here gets a layer, or pretty much get the number of layers available, I think. Yeah. And then put that back into the layer count. So we have something. Now what we need is the available layers. So std vector vk layer properties available layers. Oof. So I guess I have to do this anyways. Layers, and we're going to pass in the layer count. This is basically saying we want to allocate this block, this amount of memory, and then we get the data. Oh wait, yeah. We need to allocate enough memory so we can... What a vector is a dynamic array, but it starts out with like 5 open blocks before it starts copying and taking up usage. If we just say, hey, we already have this, or we're expected this much, then there's not gonna be as much copying. Advanced people already know that, but just for the beginners. So VK enumerate instant layer properties, layer count, and available layers. Data. What the data is just returns a pointer to our memory, and it just fills up all the objects that we need. So we got the available layers. And this just going to go through those, so create info, enable validation layers. Oh, all of that is just checking. Yeah. So enable validation layers. So let's see, enable layer count and PP enabled layer. Layer names. So I'm actually doing something different. I'm gonna get rid of that because that was actually gonna check if we have the layers, and I'm not gonna check it. Even you're supposed to, but I'm not doing it right now, I guess. So create validation layers. Okay. If validation layers that size is more than 0, we want to do this. And we want to static cast this one. Because dot size is just an integer, and we want an unsigned 32-bit integer. But yeah, now we need to set up a message callback. So GFLW extensions, get required instance extension. This is where we need to go backtrack a little bit, because we need to add a Dix extension into the thing. So what I can do is do a std vector const char pointer validate or extension layers. And what this do is just allocates, so we can just dynamically add extension layers programmatically, I guess. Const char pointer. So what we can do from here, so we got our extension, which is a const char pointer. To be honest, we can just do that, and then just loop through. So for int 0 I is less than section count, I add 1. So since this is a array, think of this as an array of strings, pointer, because const char pointer is just a string. A pointer to a string is that. So that's what we have here. We can now do extension push back extension and then we can do GFLW extensions plus equals I. Zero. Give me a second. Maybe plus equals 1. So plus. I'm being a nerd here, but plus equals 1. Double check the stream here, see if it's all good. Yep, okay. Extensions, we're gonna add 1 to the extensions and continue on, and then extension layers dot push back this extension. So vk ext debug utils extend name. Well, I gotta go. I'm gonna kind of pause the stream at the current moment, and I'll be back.